Okay, we're in part 5 of the exponents videos. Now we're going to get more into, you're going to have negative exponents more, and you're solving for equations. And as you can see, all the numbers, you should be able to recognize, what their powers of something. There always are, okay, if you're solving these kind of equations. So let's do number 1, a simpler one. I like to start from the beginning, easier one, and then a little more harder. But I don't usually make it too hard like on some of these problems. Um, but they're challenging enough where you'll understand a good grasp of this concept of exponents. So let's start with 3 to the negative 2 power equals to 1 over 27 to the 4x power. So how do you solve that? So first of all, they have the different bases. That's the first thing you should always recognize. Right now, we're working with different bases. If they're the same, it'll be very easy. But if it's different bases, you got to make this base the same as this. So 27, you're going to recognize one right away that is a power of 3, right? Because you got 3, 9, 27, 81, 243, okay? So 27 is the same thing as 3 cubed, or 3 negative 3, because it's 1 over 27. Because a negative exponent, you do the reciprocal. So this is really 3 to the negative 3 power, okay, to the 4x power. And then we can write the same way here, okay. So we have now 3 to the negative 2 power equals to 3 to the negative 3 power times to the 4x power. So let's combine that together, and you'll get 3 to the negative 3 times 4x, because you're doing power, remember. So you get 3 to the negative 12x power, because negative 3 times 4x is negative 12x. Now the bases are the same. Now you can set these equal. So you get negative 2 equals to negative 12x, okay? And all you do is just divide by negative 12. You just solve, algebra, and you'll get 1 over 6, okay? So that's number 1, okay? Not too difficult, like maybe 2 or 3 steps. Okay, number 2, you'll get 8 to the negative 4x plus 4 equals to 16 to the negative x. Different bases again, so what do? You get 8 and 16. Well, they're both powers of 2, so let's make them all powers of 2, and you can set them equal, right? So what's 8? 8 is 2 to the 2 cubed, right? So 2 cubed. And you just copy that, negative 4x plus 4. Okay, and you can figure out 16. 16 is what? What power of 2? That's 4, right? So now you got 2 cubed to negative 4x plus 4 power times equals to 2 to the 4th power time, to the negative x power. So now let's use this power, okay? So you multiply them together. So you get 3 times negative 4x plus 4. So we have to use the distributive property, right? So 3 times negative 4x is negative 12x. Okay? 3 times plus 4 is plus 12. Okay? Equals to 4 times negative x, because power, remember? So you get 2 to the negative 4x. Okay. So now the bases are the same. You see, it's 2. Now you can set the exponents to equal to each other. So let's rewrite this over here. Okay, so let's solve for x. Let's move x over to the right side, since there's a number here already. So you add 12x. And you will get 12 equals to 8x. Okay, and then you divide 8 on both sides. Okay, then you'll get 3 halves equals to x. Okay, and that's how you do this problem. Now the third problem, you get 1 over 81 to the negative 3x equals to 27 to the 4x plus minus 6 power, okay? So you'll recognize right away 27 and 81, they're powers of something. What power are they? Powers of 3, right? So let's do 81 first. So 81 is what power of 3? Well, it's 3 times 3 is 9, so it's 3 squared is 9. 3 cubed is 27, and 3 to the 4th power is 81. But it's 1 over 81, so it's not 3 to the 4th power, it's 3 to the negative 4th power. Because when you have a negative exponent, remember, it's a reciprocal. So this is really 3 to the negative 4 power. and then copy again, negative 3x equals, now we have to figure out 27. 27, 3 times 3 times 3, which is 3 cubed, right? So 27 is just 3 cubed, and then copy 4x minus 6. Okay? So now you got 3 to the negative 4 power to the negative 3x power equals to 3 cubed to the 4x minus 6 power. So use the power again. Okay? So negative 4 times negative 3x will be 12x, right? Let me write it over here. And 3 times power again, 3 times 4x minus 6. So you got to use the distributive property here. Okay? So 3 times 4x will be 12x minus 18. This is an interesting problem, okay? You'll see why very soon. So you got 12x equals to 12x minus 8. Okay, so that's really awkward, right? It's like 12x on both sides, so what's going to happen now? Well, if you subtract 12x on both sides, you end up with 0 equals to negative 8. So how can that be? Well, what happens when you have something like this where 12x equals to 12x? That means pretty much it's all solution. Any solution will work. So it just happens that way. I mean, I make up all these problems on my own. But the thing is, once in a while, you will see something that weird. And when you see something that weird, you have to ask yourself, oh, what do you do now when the 12x's are canceled on both sides? I'm sure you've seen it before. And you just kind of look at it and it's like, what do you do now? What does that mean? It just means that any x you put in here, you get the same answer as long as it's not like dividing by 0 or you're taking a square root of a negative number. But it doesn't seem like there's anything right here. So the answer is just anything, all set. Very interesting problem. So that's my review of exponents. This is lesson 5. If you need more, we can move on to lesson 6, but I'm not sure if we're going to do any more problems. I'll move on to something else.